I am telling you about the applications of potentiometer. There are so many applications, and these all are related either with the EMF of the cell or the potential difference or the comparison of the EMFs or the measurement of the resistance, etc. So first application that I am taking here is the comparison of EMF of two primary cells. So here that I make here I have taken the two primary cells E1 and E2 of EMF E1 and E2, and I have told you earlier also that all the changes will be made in the secondary or the auxiliary circuit. There is no change in the main circuit. So this is the main circuit. Main circuit. This is the auxiliary circuit. Now this X, Y, Z, this is a two-way key. Two-way key. This is one method of measuring the comparison of the EMF. I will tell you one more method for comparison of EMF of the two cells. The current from main circuit is passed through the wire AB. Let E1 equal to EMF of cell and E2 is the EMF of another cell of cell 1. This is now your cell 1, this is now your cell 2. E2 EMF of cell 2. This is now cell 2. So what we do? In the two-way key, first we connect XY and then connect YZ. When we connect XY and find the valence length of the potentiometer wire, then XY is disconnected and the connection is made between Y and Z, and then again the balancing length L2 is find out. So let X equal to potential gradient. Potential gradient. And for cell 1, this cell 1, this cell 1. Now this E1 equal to XL1. XL1, L1 is the valence length. the jockey is slided on the wire AB and no deflection is obtained in the galvanometer, and that length is measured. So that is now suppose this L1. Now for cell 2, this E2 equal to XL2. So just we compare this E1 upon E2 equal to L1 upon L2, where L1 valence length and L2, this is also valence length for cell 2 of cell 2, and this is of cell 1. So this will give you the comparison, or we can write it to be E1 ratio E2 equal to L1 ratio L2. This is one way to compare the EMF of the cells. Now there is one more method. One more method. This is what? This is the potentiometer wire. RH, this is now your K, this is XY, this is E0. And then we are having this is AB, this is now jockey J. Now here we are having this EMF. This is your E1, this is E2, here E1, this is E2. Now this is the current I in the potentiometer wire. So in the first branch we have shown the E1 and E2 are in the same direction, so they are supporting to each other. And here the E1 and E2 are in opposite, so they are not supporting to one and each other. So first we have, now for this is now your X, Y and Z. First we connect X, Y and then find the balance length for E1 and E2, and again disconnect this X, Y and connect the Y, Z, and again find the balance length L2 for cell E1 and E2. This is one more method. Here they support, so this E1 plus E2. Here they do not support, so this is E1 minus E2. Now here we can have when cells support each other, then what we have? E1 plus E2 equal to XL1. This is now 1. When cells do not support each other, then what we have? This E1 minus E2 equal to XL2. This is now number 2. Here we have taken that this E1 is greater than E2. So what we have? Just keep dividing. equation 1 by 2. So what we have? This E1 plus E2 upon E1 minus E2 is equal to XL1 upon XL2, and definitely here this L1 is more than L2. L1 greater than L2. Then what we have? This x and x will cancel. So we have this E1 plus E2 upon E1 minus E2 equal to L1 upon L2. Just a cross multiply. E1 L2 plus E2 L2 equal to E1 L1 minus E2 L1, right? So just you transpose all these terms on this side, and or we are having this E1 into L1 minus L2 minus E2 into L1 plus L2. So we are having this E1 upon E2 equal to L1 plus L2 upon L1 minus L2. This is the formula. So we can also compare this EMF of the cells when they are supporting to each other and when they are not supporting to each other. So we can have this formula also. So generally the question that is given in the board exam or in the competitive exam is like this one. There suppose two cells are there and for the balancing length for them is so much when they are supporting each other, and when they are not supporting the balancing length is so much. Now compare the EMF of the two cells. So just you L1 plus L2 upon L1 minus L2, that you take out. Whichever is more, that you take. So this will be the comparison of the EMF of the two cells. Now I am telling you the measurement of internal resistance of cell by potentiometer. Now second application. Measurement of internal resistance of primary cell by potentiometer. So about the internal resistance of cell, the question in the Rajasthan board is asked like this one, that define the internal resistance of the cell and the factors that affect the internal resistance of the cell. This I have told you earlier when I taught you about the electric cell or the electrochemical cell. So just you write down the definition from there, and then how to measure it with the help of potentiometer, that I am telling you here. Now we are having this This is the wire AB, and resistance box. This is now key K dash E. This is the current I that goes here. So this is the circuit, this is the main circuit. This is main circuit. The current from main circuit is passed in potentiometer by AB. Let E equal to EMF of primary cell and R equal to internal resistance of cell. So what we do? Now here this we are having two key K and K dash. First we keep this K dash open and then K is closed so that the current is passed in the wire AB. When key is kept open, then circuit, this cell is in open circuit. By keeping key dash open, the balance length is obtained. Let L1 equal to balance length for EMF of cell. So this E equal to X L1, this is now number 1, X where X equal to potential gradient. Key K dash is closed and external resistance R is applied. In circuit. Again balance length L2 is obtained. So now we have, when we have inserted this resistance from the resistance box, R is applied in circuit. तो R कहाँ से अप्लाई करेंगे? रेजिस्टेंस बॉक्स से करेंगे. इसमें बहुत सारी की होती हैं, उनमें से क्या करेंगे, कोई सी भी एक की हम बाहर निकाल देते हैं. सपोज करो आपने 10 ओम की एक प्लग बाहर निकाल दी, तो 10 ओम का रेजिस्टेंस लग गया उसके अंदर. अब उसमें कितना उसके अंदर जो बैलेंस लेंथ होती है ये हम इसमें प्राप्त कर लेते हैं बाय स्लाइडिंग द जो कि J ऑन द वायर AB. सो नाउ वी हैव टर्मिनल वोल्टेज V equal to XL. This is now number 2. The internal resistance R equal to E minus B upon B into R. This we know. Now put the value of E and B from 1 and 2 in this equation. So what we have? Substituting the value of E and V. We get so this R equal to this is so much, and always remember that E is always greater than 1. L1 is greater than L2. So by using this formula, you can obtain the internal resistance of the primary cell. So this is how to measure the internal resistance of the given primary cell. So thank you.